Welcome. The ITRC Passive Sampling Technology Update team is proud to present an overview of the Snap Sampler technology. This quick video will provide a high-level overview of the device as well as instructions on how to use, deploy, and retrieve the sampler. For more information on this and other passive sampling technologies, please visit the Passive Sampling Technology Update Guidance document.
The Snap Sampler is a grab-type passive sampler that collects whole water samples at a fixed depth of up to 2,500 feet below ground surface. The device is primarily used to sample groundwater, but can also be deployed to sample minimally flowing surface water, such as a pond or lake. When assembled, the Snap Sampler is designed to position a sample container within a well or water column until triggered for container closure. The sampler can be deployed in wells with casings 2 inches and larger in diameter, and to depths exceeding 2,000 feet. The sampler body holds one sample bottle. A range of bottle capacities are available from 40 milliliters to 350 milliliters. Each sample bottle is designed with a closable plug on both ends to allow unimpeded movement of water through the bottle, up to the time of triggered closure. A key feature of the Snap Sampler is its ability to be connected in a series of up to 6 samplers, as shown here, and to mix bottle sizes within the sample train. When assembling the sampler, especially a series, a covered tailgate or work table can be helpful. Each sampler is linked to the trigger mechanism by cable connectors, so that one activation triggers all sample bottles in a series to be closed simultaneously. Individual sampler bottles are shipped in sealed and protective packaging. Let's take a closer look at the sampler bottles. The 40 milliliter bottles are equipped with SEPTA-seal caps on both ends. The snap assembly consists of 2 tapered, snap caps, connected with an internal spring. When deployed, the plugs are held open by the Snap Sampler mechanism, allowing groundwater to flow through the bottle until the time of sample collection. The 250 milliliter bottle is designed for 2-inch wells and requires a different sampler base compared to the 4-inch well bottle and sampler. Loading the Snap Samplers will depend on the bottle size, as each have a different shape. Loading techniques for the poly bottles and 40 milliliter glass bottles are shown here. The difference between the two is that glass bottles are inserted into the top of the sampler, while the poly bottles are inserted from the side. Each individual sampler can then be attached to the trigger system. 2 tools are required for sampler assembly and disassembly: a pair of end cutters and the Snap multi-tool. Prior to capping the sampler with the SEPTA caps, the end plugs on the bottles will need to be trimmed with the end cutter. The Snap multi-tool is used to level the snap caps into the set position and to lock the cable connections between samplers. A key component of the Snap Sampler is the mechanism used to hold open the ends of the sample bottle and the specialized end plugs connected with a spring. Triggering the closure mechanism moves the blue plastic assemblies into a retracted position, freeing the end plugs to snap down and seal the sample bottle. Once set in the locked open position, the tab is trimmed with the cutter to the mark embossed on the tab. This trimming avoids accidentally tripping the mechanism. Individual samplers are attached to a coupler to create the assembly. Each sampler is then linked to the trigger mechanism by cable connectors, so that one activation triggers all sample bottles to be closed simultaneously. Once assembled, the Snap Sampler is ready to deploy. Each well has a dedicated sampler with pre-selected and measured tubing, made for a specific depth. Tubing is used for support, and to connect a surface air pressure source to the pneumatic plunger located at the top of the assembly. Once the support tubing is connected to the sampler, it is lowered into the well. It is useful to have 2 workers available, although this step can be readily performed alone. Once lowered into the well, the tubing end fitting is locked into a notch in the well head assembly, prior to covering with the sealed locking cap. The pneumatic actuator connected to the assembly is activated with an air pressure source at the surface with the air carried down through the support tubing. A battery-powered air compressor and gauge manifold are available to simplify the process. The pressure gauge allows confirmation of pressure buildup, and then successful release when triggering is completed. Once triggered, the entire assembly is raised out of the well by coiling the tubing. To access the closed sample bottle once the sampler assembly is removed, each individual sampler is disconnected in the following sequence. To disconnect a sample train, first, separate the trigger cables from each sampler. Then loosen the set screws slightly. Twist the sample bottle housing to separate it from the connector. Then the sample bottle can be removed. Remember, different bottle sizes are loaded differently. 40 ml glass bottles are retrieved from the top while poly bottles are retrieved from the side. The process is repeated until all sample bottles are retrieved and then inspected. After retrieval and sampler disassembly, the filled bottles are ready for processing. If needed, the spring can be removed without disturbing the sample. The bottles will need to be trimmed before capping them with the Septaseal caps. Using the end cutters, the remainder of the trigger tab is cut off and removed. Some of the key advantages of the SNAP sampler are: the device collects a whole water sample, which allows for the analysis of dissolved or suspended chemicals. It collects an unfiltered and undisturbed sample in a container sealed at the moment of bottle closure, largely avoiding sampling artifacts, such as turbidity, or collecting the sample from a non-targeted sampling position. For reoccurring sample events, the collection occurs at a consistent depth. The sampler can be deployed to depths of up to 2,500 feet. The device can sample low-yield and short water column wells, and can reduce investigation-derived waste for projects. Some limitations include: the sampler must be deployed in wells 2 inches in diameter or larger. In the past, some components of this sampler may have contained PFAS, which should be considered based on project data quality objectives. But PFAS-0 bottles are now widely available, which are entirely PFAS-free, as are the rest of the components of the SNAP sampler. The volume collected by the sampler is limited. Some important takeaways about the SNAP sampler include: the device can be used in groundwater and surface water applications. SNAP samplers can be used to sample a wide range of chemicals, but are subject to volume limitations. The samplers are effective for sampling low-yield and short water column wells. The device can be deployed to extreme depths. Multi-level sampling is possible and effective with the SNAP sampler, especially in wells with a diameter greater than 2.5 inches. Sample consistency and waste reduction can be achieved for long-term monitoring. Remember, you can learn more about the SNAP sampler and others in the ITRC Passive Sampling Update online guidance document.